All right, let's go ahead and do notes. We're going to call it 12A. It's Unit 9. Okay, so we have prime numbers. The prime numbers include numbers such as 2, 3, 5, 7, 11, and so on. You won't need any numbers bigger than like 5 or 7 for this. Expanded form is like, for example, if you have 10, 10 is the same thing as saying 2 times 5. 12 is the same thing as saying 2 times 2 times 3. Or you can write it like this, 2 squared times 3. Expanded form, this would be expanded. Expanded form. And then this one right here is exponential form. So we'll write an expanded form for this page today. Let's look at the first example. We want to simplify this by expanding. So don't just write the answer. I know this one's really easy, like elementary stuff, but I want you to expand it just to show that you can remember how to expand. 2 is just 2. That's a prime number, so we can just leave it as 2. 8 is 2 times 2 times 2. Well, you just cross out the ones that are the same, and if you cross everything out, it gives you a 1 at the top. So we have 1 over 2 times 2, which is 4. So your simplified expression, your simplified fraction is 1/4. Let's look at the next one. We have 10 over 100. Well, if you were to write it in like prime factor expanded form, it'd be like 2 times 5, or 2 times 2 times 5 times 5. One of the 2's cancel out, and one of the 5's cancels out. And so you have 1 over 5 times 2, which is 10. Now, you could just write it out like this, and I would accept that as well. Either one of those is fine. Now, for C, we have 4/10. 4/10, we're going to have 2 times 2 and 2 times 5 for the 10. Well, the 2's will cancel out, so you're just left with 2/5. For D, we have 9 over 12. Well, 9 is 3 times 3, and 12 is 3 times 4, and 4 is 2 times 2. The 3's cancel, so you're left with 3 at the top and 4 in the denominator at the bottom. Okay, the last two on this first page, we have 16 over 4. That's the same thing as 16 divided by 4. That's a whole number, it's 4. So that's the answer. If we want to write an expanded form, we could do 4 times 4 over 4. We could also do a bunch of 2's. You could show either of these. I would take the, I'll give you the credit for showing either or both of those. And then 20 over 6, that's 2 times 2 times 5 over 2 times 3. The 2's cancel. You're left with 2 times 5 in the numerator, that's 10. And the 3 is in the denominator. Okay, let's look at this top part in the box. Rational expression. A fraction whose numerator and denominator are non-zero polynomials. The numerator is the top, the denominator is the bottom. Numerator is also known as the dividend. And the denominator is also known as the divisor. For wholes, you want to set the canceled expression equal to 0. And for the vertical asymptote, you want to set the denominator equal to 0. And you do this after finding the wholes. And together, these are considered the excluded values. So if it ever says write your excluded values, you would just put the wholes and the vertical asymptotes, VAs. Okay, on the second type of examples, we're going to simplify and state the excluded values. Okay, so on A, we have n plus 4 over n plus 4 times n minus 4. Just like on the front page, we're going to cancel out the like factors. The like factors is what you're going to use to find the wholes. So to find the wholes, we have n plus 4 equals 0. We just say equal to 0. So n is going to equal negative 4, so we put that right here. To get the y value, you just plug in negative 4 for n for what's left over. So we have 1 over n minus 4. We're going to plug in negative 4 for this. So we have 1 over negative 4 minus 4. That's going to be 1 over negative 8. So we have negative 1/8 right here. To get the vertical asymptote, after you found the whole, you're going to set the rest of the denominator equal to 0. So we have n minus 4 equals 0. Add 4. So n equals 4. So you just put 4 in that blank. Let's do the next one. So we have a minus 5 times a plus 1 all over a plus 1. The two there are the same as a plus 1, so those cancel out. Set that expression equal to 0 to find your whole. So a equals negative 1.
Why are you doing negative 1 when the only one is 4? I meant 5.
For finding the wholes, we want to set the expression that we cross out equal to 0. And then to get the y value, you plug in the answer you just got into what's left over. So this would be negative 6. And then there's nothing left of the denominator. You just have a minus 5. So there's no vertical asymptotes, because 1 can never be 0. Let's look at C. So for this one, notice that there's nothing that's the same in the numerator and the denominator. This one has a minus 3, this has a plus 3. This has a plus 10, this has a minus 10. So that's why we put none. So this one's already simplified, so we just copy the same thing down for our answer. And we're going to have 2 vertical asymptotes. We're going to set x minus 10 equal to 0, and we're going to set x plus 3 equal to 0. Add 10, subtract 3. So you have vertical asymptotes at x equals negative 3 and x equals 10. Let's do D. We have y plus 1 times y plus 5 all over y plus 5 times y plus 1. Does the y plus 1 cancel with something? Yeah. How about the y plus 5? Yeah, everything cancels, so you're just left with 1. There's nothing in the denominator, so there's no vertical asymptotes. For your wholes, though, you're going to set both of those equal to 0. Y plus 1 equals 0, and y plus 5 equals 0. Subtract 1, y equals negative 1. Subtract 5, y equals negative 5. So we have negative 1 and negative 5 here. The output will always be 1, so that's our output values. We'll call it capital Y in this case. Alright, we have 2 more on this page. Let's look at E. We have m minus 2 times m minus 2 all over m minus 2 times m plus 2. What happens to these m minus 2's? They cancel out. Is this going to be a whole or a VA? Is it a whole or a VA? A whole. That's it. What cancels out is the wholes. Add 2. M equals 2. And then we're going to put it into our simplified form to get the output. It's just 0 over 4, that's the 0. So we have m minus 2 over m plus 2. There's a vertical asymptote. Where we say equal to 0, what do we put right here? M plus 2, yeah. Subtract 2, m equals negative 2. I don't know why I put an n. It should be an m. Alright, let's look at the last one on this page. We have p plus 4 times p plus 4 all over p plus 4. Well, something cancels out as the p plus 4s. What is that? Is it whole or a VA? Whole. Let's set that equal to what? 0. Solve for p. So your p is negative 4. Put it into your answer to get your output. It's just 0. So you're left with p plus 4. And I want you to do the practice on your own on the next page.